The second type of chemical bond to describe is the ionic bond. Ions are atoms that have lost or gained an electron, and an ionic bond is an electrostatic attraction between two ions of opposite charge. So to describe the formation of ions and the formation of an ionic bond, let's look at sodium and chlorine. And remember, sodium chloride is the name of the compound, which is table salt. And in an ionic bond, the ion that gains an electron, or the anion, is often given an IDE ending, which is why the name chloride is different than chlorine. We don't see that in covalent bonds, only in ionic bonds. But first, let's look at these atoms themselves. And if I fill up the shells of a sodium atom, 2 in the first, 8 in the second, and then 1 in the third. So the atomic number, or the number of protons in the nucleus, is 11 for sodium. We find it as number 11 on the periodic table. 2, 10, and 11 electrons fill the shells in the way that you see. This is the valence electron. The valence number is 1 because this electron will be lost in order to fill up this outermost shell now. So this shell will no longer have any electrons in it. And what that does is it gives the sodium ion a positive charge because it's lost something negative. Now chlorine, on the other hand, has an atomic number of 17. And so it has 17 electrons, 2 in the innermost shell, 8 in the second, and 7 in the outer shell. And as these two approach, this electron will transfer to fill up this atom's outermost shell. And that'll give the chloride ion a negative charge, a -1 charge, because it's picked up 1 electron from something else, in this case, sodium. Now, sodium has a filled outer shell, and so does chlorine. And these two are attracted to each other based on the single positive and single negative charge. And that is an ionic bond. Here is a little crystal of table salt. And table salt is basically just a bunch of sodium and chloride ions interacting with each other by electrostatic interaction. And they can be broken apart by water, and I'll show you how that works when we talk more about water. But in the form that you see here, in that crystallized form, our little sodium and chloride ions are interacting with each other through an ionic bond. Now, a third type of bond is a hydrogen bond. And the best way to illustrate a hydrogen bond is illustrating how water molecules are held together in a sample of water. So every one of these is a water molecule. And inside of one water molecule is all covalent bonding holding oxygen to hydrogen. Now it's also a polar covalent bond, where this end is slightly negative, and these ends are slightly positive. So there's this hydrogen here in the water molecule that has a partial positive charge. When a hydrogen atom shares with an electronegative atom, it is attracted to another electronegative atom. So in this case, the hydrogen bond is formed between our partially positive hydrogen atom and our partially negative oxygen atom on a different water molecule. So holding together the atoms of one water molecule are polar covalent bonds. Holding two water molecules to each other are hydrogen bonds. And hydrogen bonds can occur between any partial positive hydrogen and something else that's electronegative. And we'll look at different examples of hydrogen bonds later. So kind of to summarize our three types of bonds. Covalent bonds, where two atoms share pairs of electrons. These are the strongest type of bond. And within covalent bonds, there are nonpolar and polar covalent bonds. Nonpolar covalent bonds occur when the electronegativity difference between atoms is small. And don't worry about the value, but it means they share them equally. In polar covalent bonds, the atoms share them unequally because the electronegativity difference is pretty great. So oxygen sharing with hydrogen, this is more electronegative, oxygen is, so it's polar. Of course, when hydrogen shares with itself, the electronegativities are even, so it's nonpolar. And what I wish we had in this table is carbon sharing with hydrogen, because carbon and hydrogen is also nonpolar. Then ionic bonds, these are also strong, but they do break in water. And this is when atoms lose or gain electrons to become ions, and the opposite charged ions are attracted to each other. The weakest bond is the hydrogen bond, and the hydrogen bond occurs when a hydrogen atom with a partial positive charge is attracted to a partial negative charge on something very electronegative. And a great example of that is the attraction between adjacent water molecules.